For this video, I'm going to work homework problem 20. This is going to be a slight change. We're still going to be doing a hypothesis test for a mean, but in this case, we're going to see that the population standard deviation sigma is unknown. We will have the sample standard deviation, but not the population standard deviation. Again, the steps going through through a hypothesis test for a mean didn't change. But there will be a change we're going to see as we go to work the problem whether we use a Z or a t-test. So the question to ask yourself is, when the population standard deviation is unknown, which of these tests do you use? And the answer is you will use a t-test. So we're going to apply the steps, use Statcrunch to work the homework problem, and for this one, we are given a summary of data. So here's the question. A consumer group claims that the mean minimum time it takes for a sedan to travel a quarter mile is greater than 14.6 seconds. A random sample of 22 sedans has a mean minimum time to travel a quarter mile of 15.3 seconds and a standard deviation of 2.12 seconds. So I should have went ahead and did this whole thing here. Let's see if I can go ahead and I left out the seconds. Okay, there we go. And a standard deviation of 2.12 seconds. At alpha equals 0.10, is there enough evidence to support the consumer group's claim? And again, we're going to complete parts A through D. Now, it's really important here because notice my n is only 22. They said assume the population is normally distributed. By them telling us that the population is normally distributed, this allows us to use either the Z or the t-test. But in this case, the t-test, because what do we have? We have the sample standard deviation right here, not the population standard deviation. And that's the distinction that is necessary on picking which one of the tools in Statcrunch to use. So the claim is that the mu is greater than 14.6. This will be a right-tailed test, which means since the condition of equality is not here, this goes in the claim. Mu greater than 14.6. Here's the claim. The complement of that for the null hypothesis is mu less than or equal to 14.6. The idea being that if a hypothesis test allows us to reject this null hypothesis, it would support this claim. Well, let's see what happens. So n is equal to 22. Again, I still identify the parts. You notice I'm still following the steps. X bar equals 15.3. S, notice I changed this. This is now S, not sigma, equals 2.12 because it is the sample standard deviation. Alpha equal to 0.10. So I have everything I need. So is the population standard deviation given? No. So since it is not, we're going to use Statcrunch T-Stats with a summary. After we run the test, we will see a p-value of 0.068. So p equals 0.068. When compared with a given alpha of 0.10, we see that 0.068 is less than 0.10. If the null is low, it must go. So we will, I needed to change this here, we will reject. So we're going to reject the null hypothesis. Again, the null is low, it's got to go. So we're going to reject. Okay, so let's see what this looks like in Statcrunch, and you'll see one sample, T, so the summary, sample mean of 15.3, sample standard deviation of 2.12, and a sample size of 22. My hypothesis is the mean is equal to 14.6, and my alternative is mu is greater than 14.6. Tells me it's a right-tailed test. So when I click compute, here's what I get. I get a test statistic of 1.549, I guess it would come to. I think they let us round it to 2 places, which would be a 1.55 for this question. And the p-value that I'm going to use to make my decision, 0.0682. So if I go down, well, before I do that, let's go ahead and look at how this is done in Statcrunch. So I'm going to pull up Statcrunch, Stat, T-Stats, one sample with a summary. And 15.3, my sample mean, sample standard deviation, 2.12, sample size is 22. Now, even though with a T-stat we have degrees of freedom, we don't need to do that with Statcrunch because it will make that adjustment inside the application. So the hypothesis test for equal to 14.6 or greater than, which is down here. And when I click compute, I have 1.55 for my test statistic T and a p-value of 0.0682. So let's go back to the our document, and here I've put in the completed problem. Remember, your numbers are going to be slightly different. So let's look at what I have here. The null hypothesis, mu less than or equal to 14.6. The alternative hypothesis is mu greater than 14.6. The claim is the alternative hypothesis. So when I use technology, I find the test statistic T, 1.55. The p-value of 0.068 that we've already seen shared. So I decide whether to fail or fail to reject the null hypothesis. Well, I'm rejecting the null because the p-value is not greater than alpha. It's lower than alpha. So how do I interpret this decision? Well, I think the choice is here where it is not. There is enough evidence at the 10% level of significance to support the claim that the mean minimum time it takes for a sedan to travel a quarter mile is greater than 14.6 seconds. Again, I think the choices here would have been is or is not. Remember to turn this into a percentage for your significance level. Since the claim was in the alternative hypothesis and we're rejecting the null, that means we have evidence to support the claim. And of course, the hypothesis was greater than 14.6 seconds. So I hope this helps. Well, I'm going to do question 22 next, where we use data, and then we'll do one on a proportion. So again, I hope you find this helpful. We'll have another one for you shortly.